For this video, we're going to be looking at some division problems. So number 4, I have 5 divided by 5 to the 1/3. So I know from quotient of powers, if I have the same base, I can just subtract my exponents. However, my top one doesn't have an exponent, so what do I do there? Well, when there's not an exponent explicitly written, there's really an invisible 1. So this is the same thing as 5 to the 1st divided by 5 to the 1/3. And so since they have the same base of 5, I can go ahead and subtract those exponents. So I have 1 minus 1/3. Well, to subtract those fractions, I need the same denominator. So 1 would be the same thing as 3 over 3. And so 3/3 minus 1/3, I get 5 to the 2/3. Okay, so now looking at number 5, I have 42 to the 1/3 divided by 6 to the 1/3, all raised to the 2nd power. So this one, I would recommend doing what we did for number 3, in that since I have the same exponent here, I can go ahead and undistribute that exponent. And so I get 42 over 6 raised to the 1/3 power squared. Well, 42 divided by 6, I get 7, so this becomes 7 to the 1/3 power squared. And I know when I have a power to the power, I'm going to be multiplying those exponents. So this is equal to 7 to the 1/3 times 2, which becomes 7 to the 2/3. Okay, let's look at this last one. So here I have one just like number 5. So I have 20 to the 1/2 divided by 5 to the 1/2, all raised to the 3rd power. Since I have the same exponent, I can go ahead and undistribute that exponent to get 20 over 5 raised to the 1/2 power cubed. Well, 20 divided by 5, I get 4. So I get 4 to the 1/2 power cubed. Well, 4 to the 1/2 actually gets me a whole number because the square root of 4 is equal to 2. So I get 2 cubed. And when I figure out 2 cubed, the same thing as 2 times 2 times 2, which gets me 8.